I'm going to review a couple of the problems. I'm not reviewing all of them, okay? But I am going to review a couple of the problems and kind of work them out for you just so you see them, so you understand them. All right, and then we move on. I'm going to post up this video of the review. I'm also going to post, I worked some of those problems out already on the last review that we did. I actually worked them out last night. I just got to scan them today, and I'm going to post those as well, so you can use that one and look at that as well. All right. What you see in this review is the type of problems you're going to see on the test. Everybody understand? What you see in the review is the type of problems you're going to see on the test. So I'm not doing all of them. I'm just kind of skipping around. So the first one I'm going to do is number 2. And number 2 is... All right. This particular problem only asks you, it wants you to find, it wants you to find the excluded numbers, right? And then what it says, in fact, it says, find all excluded values for the expression. What it means is it wants you to find what numbers cannot go into this equation that's in the denominator that will make it equal to 0. So the only thing I have to do then is just really just factor it and then find my numbers that wouldn't go in. So w squared minus 4 would factor into what? Anybody got an idea?
2 and negative 2.
2 and negative 2, right? So I would have w plus 2 times w minus 2 equals 0, and then do them both together. So w is equal to positive 2 and w is equal to negative 2. So my answer would look like this. That's it. I don't have to don't put parentheses around it, anything. Just simply write that. Yes?
So for like the fraction equations, are we only focused on the bottom line?
Now you're not paying attention. Look at what the direction said in that problem. That's one of the things we talked about too in ACT. Always read the directions. What is it asking you?
Find all excluded values.
And the only thing it wants you to do is find. So the other ones you got to find a domain. This one says find the excluded values. So the only thing I want to know is what values are excluded. So my answer would be what? Just this. So put a star by that so you understand what is asking for. That's the only thing I'm asking for there. All right, number 3 is find each relation. I'm not going through that. You should already know that. Number 4 is the vertical line test. You should know that one. Let's look at number 5. God bless you.
You're welcome.
And it wants you to find f as a function of 6 and g as a function of negative 3. So what do I do there?
Plug it in.
You simply just plug it in, right? So you just plug it in. So that really means, if I rewrote that, that's what it would look like. So what it is, negative 5 times 6.
Negative 30.
So I got negative 30 minus 1. So it gives me negative 31. And the second one, what am I going to plug in? Negative 3. Here's the problem with these. What is that exponent attached to? Only to the negative 3. So what's negative 3 times negative 3?
9.
Positive 9. What is positive 9 times negative 3?
Negative 27.
Good. So if I were you, I would take my time and actually write that. So that's negative, oh, I'm sorry. That is 3 times negative 27 plus 5. Right? Only thing I did was work out the exponent first. So what is 3 times negative 27?
Negative 81.
Negative 81 plus 5. So therefore g, function of negative 3, is equal to what? Negative 76. Look at number, everybody got that? Look at number 6. X minus 7 over 4x plus 4. And it's asking you to find h as a function of 1. So what am I going to do everywhere I see x? Plug in 1. So this is easy, right? Should be 1 minus 7 over 4 times 1 plus 4. Negative 6. 4 times 1 is 4 plus 4 is 8. Now, my only question to you is, can I reduce that fraction? Yes, I can. Right? What can I reduce that fraction to? That's my answer. That's problem 6. So now let's look at 7. Seven asks you to do what? Find the domain and to write it how? In interval notation. Find the domain and write it in interval notation. Right? I just have a radical there. So what would I do? How would I write it to check what I need to find? X plus 4 is what? Greater than or equal to? So x is greater than or equal to negative 4. And in interval notation, what would that look like? Bracket, negative 4.
Positive infinity. Yeah, I did it right.
I told you to skip number 8. Because we haven't done that one yet. Number 9. You down back? Good? All right. Number 9. It wants you to find the domain of each one of these functions. So we're going to do one at a time. So what are I going to do with this? Factor what? Factor the denominator, right? I'm going to create 2 binomials. What would my binomials be?
Negative 8 of 8.
Equals 0. So what I really have is that x minus 8 equals 0. X is equal to 8, right? All right, x is equal to 8. So what number can I not put there? 8, right? I know I can't put 8 there. Can I put anything else there? Yes. Because why can't I put 8 there? Because it would give me 0. And 0 in the denominator of a fraction is what type of fraction?
Undefined.
Undefined. There should be more somebody other than just OmniWiki answer. All right, it is undefined. So the only number I can't put there is 8. Can I put 7 there?
Yes.
Can I put 6 there?
Yes.
Yes. Can I put 9 there?
Yes.
10. So that means I can go on either side of 8 and put a number there, right? So basically what I have is I got negative infinity
Oh my God, I think I did that.
and 8, a union, 8 to positive infinity. Got it? Pretty easy, right?
Yep.
Everybody's got this? How did I know that I could use any other number? Because it told me that the only number that would make that equation equal to 0 would be what? Positive 8. That's the only number that would make that equation equal 0. So since that's the only number that would make it equal 0, that's the only number that can be excluded. If you think about what we've done. The first problem that we got, number 2, it asks you just to write down, give you every number that can be excluded. So you've done the same thing here. You give me the numbers that can be excluded, but you wrote in the interval notation to tell me what numbers can be included. All right, that's what you've done. So look at the next one. Same numbers, same number 9 equals x minus 5 over x squared minus 25. If I factor 25, I get what?
5 and
You get
negative
x plus 5 and you get
x minus 5.
x minus 5 is equal to 0. So what you end up getting is x is equal to negative 5 and x is equal to positive 5. Alright? So what numbers can be excluded?
Negative 5 and 5.
So only negative 5 and positive 5. So every other number to infinity on negative 5 to infinity on positive 5 and the numbers in between can be what? Can be used. So let's just figure this out. So I got negative infinity, negative 5, union, negative 5 is 5, because that tells me what? That I can use the numbers in between what? Negative 5 and 5. Union, positive 5, infinity.
Is it considered wrong if you don't put the middle thing?
Yeah, I need to put all 3 of them. You're going to see one like this, you're going to have to put all 3. You're also going to see one, if you remember, I told you have one that looks like this. Can you factor x squared plus 25?
No.
No, you can't. Right? So what numbers can go in there for x?
I mean, all.
Any number can go in there. So my answer, my domain would be what?
Negative infinity, positive.
Negative infinity, positive infinity. You're going to see one like that. If you can't factor this denominator, right, to exclude any numbers that would make it equal 0, with that one you can't. Right? You can't factor that because x squared plus 25, the two numbers would be 5 and 5, right? If I had 2 positive 5s, then what I would have is 10x in between. If I had 2 negatives, I would have a negative 10x in between. Right? So I can't factor x squared plus 25. Since I can't factor that, that means that any number can go in x and it wouldn't give it 0. It wouldn't make it 0. So therefore, if no number would make it 0, then that means that the domain is all real numbers. So all real numbers is negative infinity to positive infinity. Last one we're going to look at. We're actually going to look at 2 more, sorry. Number 11. G of x is equal to 3x squared minus 6, and I want you to find G of 4n. So I'm going to plug in 4n everywhere I see what? What's 4n squared? 16n squared. Good. So that's really 3 times 16n squared minus 6. What's 3 times 16n squared? 40n squared minus 6. That's my answer. That's it. Remember that the exponent is attached to whatever its base is. All right, its base in that case was x, and we substitute x for 4n. Substitute 4n for x. Jordan, you got that? Yeah, because 3 times is 16. And remember, you can multiply everything just by the rules of the exponents. So we keep that, because that 4n times, it's 4n times 4n. 4n times 4n is 16n squared, because you add the exponents, right? And last one that we're going to look at. So everywhere I see x, I'm going to put what? X minus 3. So if I rewrote that, it would really look like this. So what I'm going to do with the two x minus 3s? You're going to FOIL, right? So let's FOIL.
I give up. Only give up.
So all I did was FOIL the x minus 3s. Right? Because that x minus 3 is what the exponent is attached to. The exponent is actually attached to this. I cannot multiply this 4 times the x minus 3 first. Order of operations tells me to do what first? Always do exponents. So I got to get rid of that exponent first. So I FOIL the x minus 3's because it really says x minus 3 times x minus 3. So now I've gotten to this point, and I can simplify my equation. So that's 8.
Wow.
Bad, huh? I don't need any comments.
It was a
It was an attempt. What did I do? I multiplied this equation times 4. That gave me 4x squared minus 24x plus 36, and it brought the negative 5 over. Now, my final step is to combine all similar terms. Is there anything to combine 4x squared with?
No.
Nope. Is there anything to combine 24x with? Nope. How about the 36 and negative 5? Yep, so I get
31.
So this is the final answer. Alright, so the types of problems that you just saw, the types of problems that we just covered, is what you're going to see on the test.